Welcome to the session on integration, integrating f of ax plus b. The objectives for this session are to use the reverse of the chain rule to integrate functions of the form f of ax plus b. Recall that composite functions or functions of another function can be differentiated using the chain rule. dy dx equals dy du times du dx, where y is a function of u and u is another function of x. If we know the integral of a function f of x, then we can integrate a function of the form f of ax plus b using the reverse of the chain rule for differentiation. Let's take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's take a look at part A first. We are required to integrate sine 2x plus 1. So let's solve this. We begin by letting u equal 2x plus 1. And this is so that we can differentiate or explore sine u or cos u. If we differentiate u with respect to x, we obtain du dx equals 2. We also let y equal cos u, since the differential of sine is cos. And remember that we're going to use the reverse of the chain rule in order to integrate. Differentiating y with respect to u gives us minus sine u. And now plugging this into the formula for the chain rule gives us that dy dx equals dy du, which is minus sine u, times du dx, which is 2. And this is equal to minus 2 sine 2x plus 1. Now if we integrate both sides, we obtain y equals integral dy equals minus 2 integral sine 2x plus 1 dx. And therefore, since y equals cos u, which is equal to cos 2x plus 1, we obtain that the integral of sine 2x plus 1 dx is equal to minus a half times cos 2x plus 1 plus the constant of integration c. Now let's take a look at part B. We're required to integrate e to the power 4x plus 5. So let's solve this. We let u equal 4x plus 5, so du dx equals 4. We also let y equal e to the power u, since the differential of e to the power x is e to the power x. And therefore, dy du equals e to the power u. Again, we apply the chain rule to give us dy dx equals e to the power u, which takes the place of dy du, times 4, which takes the place of du dx. And this is equal to 4e to the power 4x plus 5. Now we can use the equation for dy dx equals 4e to the power 4x plus 5 to find y. Integrating both sides gives us y equals integral dy on the left-hand side and integral 4e to the power x plus 5 dx on the right-hand side. Now since y equals e to the power u, which equals e to the power 4x plus 5, we have that the integral of e to the power 4x plus 5 dx equals 1 over 4 times e to the power 4x plus 5 plus the constant of integration c. Now let's take a look at part C. We are required to integrate cos x squared 3x. We're going to use one of the standard formulae for this. So let's solve this. We're going to begin by letting u equal 3x. So du dx equals 3. The standard formula which we're going to use is integral cos x squared x dx equals minus cot x plus c. Because we're trying to integrate cos x squared of 3x. So in this situation, since we're going to reverse the chain rule, we let y equal cot u. And so dy du equals minus cos x squared u. So applying the chain rule gives us dy dx equals dy du, which is minus cos x squared u, times du dx, which is 3. And this is equal to minus 3 cos x squared 3x. Now we can integrate both sides to give y equals integral dy equals integral minus 3 cos x squared 3x dx. And therefore, since y equals cot u, which is equal to cot 3x, we have that the integral of cos x squared 3x dx equals minus a third cot 3x plus the constant of integration. There is an easier way to differentiate. In general, we can use the rule the integral of f dash of ax plus b dx equals 1 over a f of ax plus b plus the constant of integration. Let's now take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve part A first. We're required to find the integral shown on your screen. So let's solve this. We're going to let f dash of x equal 1 over x. This implies that the integral of f dash of x dx equals ln of mod x plus c, which is equal to f of x. And of course, this is an example of one of the standard integrals. And so if we apply the rule which you can see on the left-hand side of your screen to our example, as shown here, so ax plus b is replaced by 2x plus 1, and a in particular is replaced by 2, we obtain that the integral of f dash of 2x plus 1 dx equals a half f of 2x plus 1 plus the constant of integration. And so plugging in the appropriate values, as shown, gives us that this integral is equal to a half ln mod 2x plus 1 plus the constant of integration c. Now let's take a look at part B. We are required to find the integral shown on your screen. So let's solve this. If we let f dash of x equal x to the power 5, then we have that the integral f dash of dx equals x to the power 6 over 6 plus the constant of integration. And of course, this is equal to f of x. We can now apply the general formula on the left-hand side of your screen, as shown. So ax plus b equals 3x plus 2, and a in particular is equal to 3. So we have that the integral of f dash of 3x plus 2 dx equals a third f of 3x plus 2 plus the constant of integration. And so plugging in the appropriate values as shown gives us that the integral is equal to a third times a sixth times 3x plus 2 raised to the power 6 plus c. And tidying up gives us 1 over 18 times 3x plus 2 raised to the power 6 plus c. This brings us to the end of this session. If you have understood its contents, you should be able to use the reverse of the chain rule to integrate functions of the form f of ax plus b. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.